Very good. 1 minus 3x over 2 less than or equal to negative 6. Do we all agree with this? Okay, perfect. Then, of course, I have to multiply both sides by 2, and I have to multiply both sides by 2. When I multiply the first one, I get 1 minus 3x greater than or equal to 12. And I subtract 1 from both sides, negative 3x greater than or equal to 11. X less than or equal to negative 11 thirds. Do we agree with this?
Yes.
Okay. Now, the other one was 1 minus 3x less than or equal to negative 12. Of course, I subtract 1. And now it becomes greater than or equal to 13 thirds. We already know that this is the most difficult one of the two. And I have to have the union inside. So it will be something like this. And I start with the left. Negative infinity, negative 11 thirds. And to the right, 13 thirds infinity. And this is x in. Okay? Is this okay? Okay, perfect. Other question or any questions for me? Is there anything you wanted to ask? Anything that you worked on, anything that you would like to ask? About anything from anything. Oh yeah, the whole chapter is on radicals. We're going to use these rules over and over. Is there something that you worked on and you would like to see right now? Of course, we'll start with that. Because I don't know, when you say go over a radical, I'm not sure what you mean.
Like just example, like
Any example that you pick, we'll go over it right now. Anything you worked on, anything you had questions about, anything. So the last, can you just tell us what was the last problem or page number we worked on? Just the last one at the very end. Because we started 9.2, but
On 601,
yes,
on 601, number 30.
number 30 was the last one.
Yeah.
Okay, let's pick it up from there, and then you can stop me and say I want more of this or more of that. So today I think is the 10th. Okay, so let's continue with 34, which is negative 16 raised to negative 5 over 4. Write with positive exponents and then simplify if possible. So first let's rearrange this using a radical. Can I replace this by a radical? Yes, that will be first, so it's 1 over, if you want, negative 16 raised to 5 over 4. I agree. But how do I know that this is a radical or not? Because I keep talking about radicals, but how do I know it's because what?
It's got a fraction as the exponent.
Exactly. That's it. Once I say a fraction, I see a fraction as the exponent, I know it's a radical. Very good. So this must be a radical of something that is negative 16 raised to some power. What is the index? Very good. It is the fourth root. And what is the power? 5. What did we say about the even index? Something extremely important we know about the even index. Say it again. Oh, I wish. A negative number. So if the index is even, we cannot have a negative number under the fourth root. What type of number is this?
Negative.
Right, because I raise a negative number to the fifth power. So when I multiply 5 negatives, what do I get?
A negative.
A negative number. So since this is a negative number, what do I conclude? The absolute value is put on the outcome. I cannot put the absolute value on the inside of the radical. So one more time. So when I have an even index, this must be positive or 0. In this case, it cannot even be 0 because the radical is in the denominator. And the answer must be positive or 0.
So it's not a real thing.
Exactly. I will say here, not real. This is not a real number. Not a real number. Very good. Now let's look at 39.
Can you explain why it's not a real number again?
Because when I apply the even index on a negative number, it's not allowed. So see, I only have two options, positive or 0, and this is a negative number. When I multiply 5 negative numbers, I will always get a negative number. Is that better? Okay, perfect. So now in 39, we have 5 divided by 7x to negative 3/4. Now the quantity with the negative here, negative exponent, was in the numerator. We brought it down to the denominator. Now I see a quantity with a negative exponent in the denominator. Where will it go? To the numerator. You cannot change or take 5 anywhere. It has power 1. You cannot take 7 anywhere. It has power 1. So 5 7s have to stay. 5 and 7 cannot be touched. But then 1 over x to negative 3/4 becomes x to the 3/4. And if I want to change it into a radical, I will write 5 over 7, and the radical will be 4th root of x to the 3rd. Any questions? Okay, let's also look at 35. 35, we have x to negative 1/4. I cannot have negative exponents, and I cannot have fraction exponent, fractional exponent, if I want to completely simplify. So what should I write? 1 over x to 1/4, but I know that x to 1/4 can be replaced by 4th root of x. Indeed, very good, very good. Now in the next section, we will have to get rid of the radical in the denominator. For now, we are okay, but a little bit later, we will have to remove the radical from the denominator. So we don't have to talk about it right now, but just remember there is something that follows there. Okay, now we're looking at the next set from 41 through 60. Please choose. We're going to practice a lot. I mean, that's all about practice here in this
Before
chapter.
we move on, I
Yes.
actually I have a question on 39.
Please, yes.
So I see that the 3/4 is negative. The 5,
Yes.
I'm assuming then, is basically the 1 that's like in 35.
You mean 5?
Right, that's basically the 1 that's over whatever it's supposed to be because it's negative.
Yes. So this is like this here, the 1 outside.
Okay. Okay, thank you.
So this is a coefficient, if you want, of this quantity, or is a number in front of a radical. Better? Perfect. Yeah, I completely agree. Some of these radicals, when you first look at them, you say, right? Till you get used to them. I believe, in my opinion, that rational expressions are more difficult than this stuff, which is chapter 7. But you know, from my experience, students do very well on second test. Do very well. Of course, if they put some time into it and energy and effort, right? Okay, moving on. 41 through 60. Any preference? It's all about practicing the rules and simplifying.
51.
You said 51?
Yeah.
Very good. That's good. Looks awful. It's not. Just looks impressive, but it's not difficult. Okay. First of all, I would like to take care of the sign of the outcome. Positive, positive over negative. What is the sign of the outcome? Good. Let's put it outside. Now, how do I multiply two exponential notations with the same base and different exponents? Good. So I copy the base, and I have 1/2 plus 3/4. But then when I divide two exponential notations with the same base, what will I do with the exponents? Subtract. What am I subtracting now? Of course. So let's subtract 3/4 minus 1/4 first. 75 cents minus 1/4.
50 cents.
50 cents. And the first one is also 50 cents. So 50 cents plus 50 cents is
$1.
$1. So the answer happens to be negative b to the first power. What about 49? And that is 4u squared. Everything raised to 3 over 2. For u squared, everything in parentheses, raised to power 3 over 2. There are several ways here. This is what I would like to do. 4 raised to 3 halves multiplied by u raised to which power? What do I do with 2? So I have 2 times 3 over 2. 2 over 1 times 3 over 2 is 3. So u to the third. This is what I would like to do. You could change it into a radical, but I think it will be a little bit more difficult if you do that. Okay, now this is simple, no problem here with u to the third. I can't do anything to it. But this I will change into what?
The square root of
Right, there are 2 ways. Let me show you both ways. And be careful when you have variables instead of numbers. Be very careful. So the property is like this. 4 to 3 halves can be replaced by the square root, as we know, of 4 to the third. Or it can be replaced by the square root of 4, everything to the third. Sometimes this is more convenient, sometimes this is more convenient. In this case, this is more convenient because when I take the square root of 4, I get, and when I raise it to the third power, I get 8. Let's see what happens here. Here, I have to raise. I'm sorry, that was square root. I have to raise 4 to the third, and I get 64. It's not a big deal. You should say that's true. I agree. So I raise 4 to the third. It's 64, and now I take the square root of 64. Of course, I have to get the same answer, no matter what route I take. But remember, one may be more convenient than the other. When a variable is involved, you have to be very careful, however. Let me give you an example in which it will make a difference.
So would that be 8u?
Oh, yeah. Yes, thank you for reminding me. So this is 8u to the third. Very good. That's final answer. Thank you. So let me give you a situation like negative 2 to 2/3. This would be no problem. Writing it as the cube root of negative 2 squared or the cube root of 4. Or the cube root of negative 2, everything squared. This is a little bit more inconvenient in this case. So in these 2 situations, this was easier to deal with than this. Here, this is definitely easier than this. Because now I have to say the cube root of negative 2 times the cube root of negative 2. It's the cube root of 4. So this is slightly more difficult. Now if I have negative 2 to 3 halves, let's see what we get. There is a problem here. So I could do the square root of negative 2 to the third, or I could do the square root of negative 2, everything to the third. In both cases, I get the same thing, which is the square root of negative 8, not real. And the same thing here, the square root of negative 8, I don't have to raise it to the third power. I will say not real right away. In the first case, I may not see that negative 2 to the third is negative 8. So I presented 3 different situations, 3 different simplifications. Sometimes this is easier than this method. It's up to you, but just be careful. Okay, anything else from 41 through 60. Okay, 59. And then let's move on. And then we have x cubed y squared, everything raised to 1/4 over x to negative 5, y to negative 1, raised to negative 1/2. So any suggestions on the first step? What would you do as your first step? The powers. Right, exactly. I have to multiply the powers. I cannot do anything else. So I copy the base x, and when I multiply 3 over 1 by 1 over 4, what do I get? Yes. Then I copy y, and I multiply 2 over 1 by 1 over 4, and I get? Good. And then I copy x. Very good. And then I copy y. Very good. One thing I notice here, can you tell me what is that? Please do not forget to write 1. If you don't write 1, you may consider that it's 0, and mistakes start right there. So finally, I copy the base, and what happens with the exponents? Yes, always in this particular order. From the power of the numerator, I subtract the power of the denominator. So let's take that aside, 3 over 4 minus 5 over 2, and find the least common denominator. 4. So then this one needs a 2. So this will be 3 minus 10, so the top is negative 7 and the bottom is 4. So I come back and write x raised to negative 7/4. But I'm not allowed to leave negative exponents in the final answer if I say, well, fully simplify it. So this becomes? And now let's change this into a radical. Very good. Now I would like to talk about this for a moment. We will talk about it in the next section. Actually, it follows up. It just comes up right now. So, can anyone identify the index for us? 4. Can anyone identify the power for us?
7.
As long as the power is equal to or larger than the index, the radical is not fully simplified. So I will say, since 7 is greater than 4, radical must be further simplified. It's not fully simplified. So, although in this particular section, this particular section does not deal with this, I would like to address it right now. Okay. So let's look at the 4th root of x to the 7th power. 7 over 4. Is 7 over 4, is 7 divisible by 4? No. I go back 1. Is 6 divisible by 4? No. I go back 1. Is 5 divisible by 4? No. But when I get to 4 over 4, is that something that I could get an integer out of?
Yeah.
So therefore, I will rearrange the 4th root of x to the 7th into this times this, and you will tell me which powers I have to choose. One that is divisible by 4 and the other one that is not.
So 4, 4, 7, and 3 fourths.
So 4 plus 3 is 7. The 4th root of x to the 4th is simplifiable, but the 4th root of x to the 3rd can never be simplified because the power is smaller than the index. We have one property that we discussed last time that I will apply here. Can anyone tell me which property we apply now? Correct. The 4th root of x to the 4th multiplied by the 4th root of x to the 3rd. So we didn't do anything. We just presented x to the 7th as x to the 4th times x cubed, which we are allowed to. Since it's a product, I'm allowed to split it. And now, let's assume that all variables are positive. What will you write as the answer? And let's assume that not all variables are positive. They can be also negative. So I'll say here, all positive. And here not. All, or I should say better, all real numbers. So what will be answer with all positive and what will be the answer with not all positive? Or all real numbers, I should say. That's better. So what will you write as the final answer? I'm going to erase this. And this because they're not connected. So, final answer? Times the fourth root of x to the third. Excellent. And what is the answer in case x can be any real number? Very good. Very good. Thank you, Jess. The absolute value of x, the fourth root of x to the third. Very good. So please keep that in mind. Radicals are not fully simplified unless the power is smaller, not equal to. Smaller than the index. Okay, let's look at a problem like, let's say 63. I don't want to emphasize this problem too much because you are not going to frequently see this quite at all. Not at all. Okay, so here we're asked to simplify. The only thing I can do is remove parentheses. Well, in order to remove parentheses, I would have to distribute. So this quantity has to be distributed to these two terms. So when I distribute this to the first term, I copy the base. What do I do with the exponents? Very good. Yes, 2/3 plus 1. And then when I multiply by -2, all I have to write is -2, the cube root of x squared. So now how much is 2/3 plus 1? What is the least common denominator?
3.
Yes. So it will be 5/3. So this is the 5/3. The cube root of x to the 5th minus 2 the cube root of x squared. Which of these two radicals is fully simplified? You cannot do anything else to. The second one. What should I do to the first one so that I can simplify it? Of course, I have to split it in 2 like I did here. But I cannot split it in 4 and 1 because the index is 3. What should I split it into? Exactly. X to the third and x squared. So I will rewrite the whole thing. The cube root of x to the third times the cube root of x squared minus 2 times the cube root of x squared. Yes, I agree. If you don't want to write this particular step, you can skip it. But at least at the beginning, I recommend you do write it. How much is the cube root of x cubed? Assuming variables are any real number. Never on an odd index. Remember, we have 3 rules. On an odd index, that's friendly, we don't care. On the even index, only if the answer needs it. Exactly. Very good. So this is x, the cube root of x squared minus 2, the cube root of x squared. If we want to get fancy, can you please tell me what is the common factor of these two? And I want to write it out here.
6.
Common factor. A quantity that is present in both radicals, in both terms. The cube root of x squared indeed. This portion is present in both. I took it out. It's right here. What is left in parentheses?
-2x.
But what is left from the first one? What is left? So I'm here, minus. Minus 2. From the first term, x is left. From the second term, -2 is left. Any questions? Is this okay? Please? So this is a quantity. If I distribute it here, I get this term. And if I distribute it here, I get this term. So this times this is this. This times this is this. Better? Say it again. You will not see this too often, not in this class. And I wouldn't say that even in the next one. Yeah. Okay, let's move on. In number 77, we're asked to simplify the fourth root of 16x squared. The first rule that I can think of to apply here is, and what would you tell me to write?
Separation.
Yes, I recommend that. So this is the fourth root of 16 times the fourth root of x squared. Excellent. I do know the fourth root of 16 because I have a number that I raise to the fourth power to get 16. 2. Now be careful with the second portion. Is there any other way of writing this? That's true, but I have to show it. You're right. You're right. But I have to write as x to which power? 2 over 4, correct? 2 over 4. But 2 over 4 is the same with x to 1/2. And how do I now represent x to 1/2?
The square root of x.
Very good. Yes, I did simplify it. You can say, yes, but you didn't get rid of the radical. True. And what kind of simplification is this? Well, it is because I moved it down from the fourth root to the square root. And I took the fourth root of 16. What about 81? So in 81 we have the what? 12th root of a to the 8th, b to the 4th. Yes, I recommend first split it, please. So the 12th root of a to the 8th times the 12th root of b to the 4th. Then I will change the first one into a to which power? And b to which power? And I will simplify those fractions now. How much is 8 over 12 simplified by? Very good, 2/3 by 4 and 1/3. So now this is a to 2/3 and b to 1/3. Since they do have the same denominator, it means that they have the same index. Perfect. So the index is 3 for both of them. And now under the cube root, I have a to the
second power
and b to the,
1.
that's it. Excellent. Let's also do 83. And this is the fourth root of x plus 3 to the second power. Please simplify this and tell me the answer. What will be the first or the intermediate step? Very good. But 2/4 is?
1/2. So square root both of them.
We cannot split it because it's a sum.
That's it.
That's it. Any questions? More simplification of radicals. Nothing is new other than the distance and the midpoint formula, which I will talk about in a minute. But let's simplify. Page 609. Let's start with problem 5. the cube root of 4 times the cube root of 9. Let me remind you the rule that we looked at. The rule was this. Now I want to go backwards. With any index, as long as the both radicals have the same index, otherwise I can't. Do they have the same index?
Yes.
So then this will be the cube root of,
4 times 9.
that's it. Very good. What about 10? Same page, 609. The square root of 6 over m multiplied by the square root of n over 5. Do they have the same index?
Yeah.
So then I copy the index, or the radical, I should say, and I get 6n over 5m. Very good. Any questions? Any questions? One more and we move on. They may appear to be difficult, but you see they're not. All you have to do is just think in a different way. We haven't talked about, or we haven't thought of these terms before, right? Multiplying radicals. Let's look at 11. The fourth root of 4x to the third multiplied by the fourth root of 5. It says use the product rule. Of course, we will assume that all variables now are positive. Since they have the same index, I'll copy the radical. And then what do I write?
20.
Very good. So 20x to the third. So not difficult at all. They're all the same so far. Okay, that's my page 5. Okay, let's look at 18. Whereas the fourth root of y over 81x to the fourth. The fourth root of y over 81x to the fourth. What will you do first? Yes, I highly recommend it. The fourth root of y over the fourth root of 81 multiplied by the fourth root of x to the fourth. We assume everything is positive. I'm only applying the rules that we discussed. Nothing new yet. So, the fourth root of y. Can anyone simplify the fourth root of y?
Y to x 1.
No? Yeah, if you would like to write y to 1/4, but nobody can simplify it. Other than that, if you want to rewrite it, but it's not, I'm not simplifying it. Good. 3x. What if you were told that x can be any real number? Or y can be any real number? Well, here we didn't do anything. So what about the denominator? Will you change the denominator if you were told?
Absolute value.
Yes, I will put the absolute value if I were told that x can be any real number. Very good. (27) 610 on page 610. Square root of 5x squared divided by 4y squared. We assume everything is positive, and I'm sure you will split it into the square root of 5, the square root of x squared over the square root of 4, the square root of y squared. We are allowed to, because there is no sum or difference. We cannot split the sum or the difference under this root.
Can't you just make it
Yes.
square root of 5x?
Right, but I will put x in front. It's not a mistake. It's not a mistake to write the square root of 5 times x. However, we try to avoid the confusion of saying, oh, do I extend this over or not? So we don't want to put the radical in front of anything. So we prefer x, the square root of 5, and there is no confusion. Is this correct to write the square root of 5 times x? It's perfect. But avoid putting a square root in front for that reason. Very good. And the denominator is, so it's 2y.
Why is it 2y?
It's the square root of 4. Okay, very good. Let's also look at 29. And this is negative outside, and then the cube root of z to the 7th over 27x cubed. Okay, let's work on this for 1 minute. Is it warm in here or is it me?
Yes, it's warm.
I put it on cold, but that's what happens in this room. So please pay attention or be careful. It's either cold or hot. Very little in the middle.
It's a cube root of 27, not 9, 3.
Yes, yes. Because 3 times 3 is 9, 9 times 3 is 27. Okay, are we ready? So the negative stays outside, and then I know that I have to split the cube root of z to the 7th, and the cube root of 27, and the cube root of x cubed. So what about the denominator? So minus outside, and the denominator will simplify into?
3x.
Right, 3, the absolute value of x, or just 3x?
It can be the absolute value.
Because it's a cube root. Very good. Excellent. Now I have a problem with z to the 7th. Yes, I will split in the cube root of z to the 6th times z. Here's how we think about this. 7 over 3 is not an integer. I move on down 1 by 6 over 3, and this is what I need. So I need 6 and 1. What if I put 3, 3, and 1? Yeah, but you work too hard. It's up to you. I'll accept it, of course. So then now what is the top? Of course, you have to split it again. The cube root of z to the 6th times the cube root of z over 3x. And one of them will be simplified. Which one?
So like z to the 2nd.
Very good. Excellent. That's it. No one can further simplify this. Yes, please. John?
I thought you said that as long as the radical, I mean, the exponent.
Yes.
The thing is bigger than the index, you can simplify.
Correct.
So why don't we just sum over, why don't we sum over 6 and 6 and 3? I know it can be, you can do it that way, but like, I thought the rule was as long as it's bigger.
Right. That's why we didn't leave it as the cube root of z to the 7th. Yes.
So would it be wrong if you split it into 3 and 4 rather than 6?
But 4 is not enough. It's 4 over 3. It's still bigger than 3. You have to go maximum. So you start going backwards. 7 over 3, no. 6 over 3, yes. That's where you stop. You don't go down to 3 and then come back to 3 again because you have 4.
I got it.
It's not a mistake. So see, there are several ways. So I can write z to the 7th as z to the 6th times z, or I can write as z to the 3rd times z to the 3rd times z, but then I will be applying 2 radicals instead of just 1. But I cannot write the cube root of z to the 3rd times z to the 4th, because that's not good enough. Z to the 4th is bigger than index 3. So always go backwards. 7 over 3 is not good, but 6 over 3 is. So that's why I need 6 and 1. Better? Perfect. Other questions? Okay. Let's go to the next set of 31 through 60. These are all different situations in which we apply the same rule. Okay. Any preference? 1, 2, 3. 43. In 43, we have the 4th root of a to the 8th, b to the 7th. Here I claim that one is nice and what isn't. Yes, the fourth root of a to the 8th is nice, but how will I write the fourth root of b to the 7th knowing that b over 4 is not an integer? Go back one, back one, back one till you find what you need. 5 and 2 will not work. So 7 over 4 is not good. 6 over 4 is not good. 5 over 4 is not good. So I have to stop at 4 and 3. Yes. So then b to the 4th and b to the 3rd. So now the first one is? Very good. That's done. The fourth root of b to the 4th is? Very good. Or maybe the absolute value, but we are told everything is positive. And the radical that cannot be simplified any further is the fourth root of b to the 3rd. Excellent. Yes, this, yes, please. Alexis.
Didn't mean to interrupt. I just picked my sister.
Say it again.
Oh,
Oh,
I
yeah.
picked my sister.
Okay,
Sorry about that.
it's okay. So please watch the videos and please print out the notes.
Did you upload them after your class, right?
Yes. I did that. So far, I did not fall behind with, oh, I have a lot of stuff to return to you. I forgot. Oh, I don't want to take it back. I just finished it. Oh, look, I had some paper. Sorry about that. Okay, thank you. Because you know I don't want to carry anything. I can't avoid it. Wednesday.
You know what I've realized about this class?
I'm sorry?
You know what I realized about this class? I need like 3 of these for my notes.
Right. Yeah, I agree.
And then 1 from my homework.
I agree. I completely agree. I know.
We teach the math for
Yes, just after this class.
so if I can pick for next semester too.
You can pass the course.
Oh, I think I might be.
She came for you.
I think I'm gonna be good.
You as our teacher.
Oh, it's like
Of course, it will be an honor. Every time I have a student who comes back, I say, gee, she or he wasn't tortured enough. She comes back for more. But I'm very happy to see my students.
Isn't that algebra and trigonometry?
Yes, it is.
Yeah, I need to know.
Did I give you two?
Yeah, I got one.
Oh, yeah, by mistake, I gave you two, sorry. No, I know you're not.
This isn't me.
Oh, Lord.
Did I return yours?
Yeah.
Okay, okay. Of course, I know you. It's not you. Okay, I think I have one more, don't I?
One more, yes. One more quiz. Right?
I have one more to return, right? Quiz 6, right?
No, I have quiz 6.
Okay.
That's it?
Okay, so I don't have anything else, right?
No.
Okay, very good. See, I have less to carry now. Perfect. Thank you for bearing with me. Okay, so this was 43. Let's look at 53, which is negative the square root of 32, a to the 8th, b to the 7th. Okay, now in this case, we have three different situations. We have the square root of 32, we have the square root of a to the 8th, and we have the square root of b to the 7th. But only one of them is nice. Does not need any effort on our part. Which one is that? Yes, because this is a to the 4th. Oops. Now, let me draw your attention to something. There are many students who do this. The square root of a to the 8th is the square root of a to the 4th. What's wrong with this?
You're not doing it right because you're dividing by 2, so you don't need the square root.
Exactly. I already applied the square root. This is like saying that the square root of 9 is the square root of 3. It's incorrect, right? Once I applied the square root is gone, and I apply the square root of 9 and I get 3, correct? Okay, perfect. So now I have to split 32 as well as I have to split b to the 7th. How do I split 32? Maximum.
16 and 2.
Yes, indeed, 16 and 2. How do I split b to the 7th? Very good. B to the 6th and b. So I will rewrite everything for everyone to see. Negative stays outside. The square root of 16 times the square root of 2. Bless you. Times a to the 4th times the square root of, oops, I cannot write today. A to the 6th times the square root of, oh, it was b, of course. Times b to the 6th times b. Very good. So now slowly, please, can anyone tell us?
So then simplify the 16 to 4,
So this is 4.
and then the b to the 6 would be b to the 3.
So negative 4. A to the 4th, 6 divided by 2, b to the 3rd, and now this and this have to stay under the same root. This is useful, but not a lot of variables. If it's more than 2 variables, it's not that useful, but it's the same thing for the future, I mean, in math. Okay, let's look at 67 on page 610. I want to make a point about these problems from 61 through 76. 61 through 76. We're going to write a note here. Let me copy the problem first. So the square root of x to the fifth, y to the fifth, no, y to the third, divided by the square root of xy. Let me explain the note, and then we'll write it together. Can you see? So it's the square root of x to the fifth, y to the third, and the square root of xy. Remember the rule, this rule. Square root of a over b equals the square root of a over the square root of b. But this goes back and forth. If I have this, I can recover that. If I have this, I can recover that. In this case, I have this. This was what I'm given, and I want to get this. Why do I want to get this? It's because I see the same factors. See the difference. If I have the square root of 5 over the square root of 3, although I can write it as the square root of 5 over 3, I will not, because I can simplify it. 5 and 3 have no common factors. This expression, top and bottom, they have common. Those two expressions have common factors. That's why I will write one radical and have x to the fifth, y to the third over xy, because I can simplify inside the radical. But here there is no point in writing the square root of 5 over 3. There is something else we do with this to simplify it. But there is no point in writing this even if it's correct. It's correct, but it will not simplify. So that's why we don't need it. Here, we do. So I will write a note like this. Condense under the same radical if there are common factors that can be simplified. So note, condense an expression under the same radical only if there are common factors that can be simplified. Let me read the note. Condense an expression, condense it, use the same radical, under the same radical, only if there are common factors that can go away.